Hey guys, I hope that you're doing well. And so we're finally diving into chapter 5 here. Okay, and chapter 5 is going to be about performing operations on polynomials. So we're starting with adding and subtracting polynomials because they're the very similar operations. Well, the first question I hope you have is, well, what's a polynomial? It's actually kind of an easy definition because if you study Latin, which most of us do not, it breaks into two kind of Latin roots. Poly means many, like a lot of, or multiple of. And nom, or nomial here, that actually means names, which loosely translates to terms. So it's many terms. Well, then you should kind of have a next question then. You say, that sounds all fine and dandy. Okay, then what's a term? What is a term? Well, let's see if I can give you an idea of what a term is. We just did all those exponent rules, and each exponent rule applies to single terms. Terms are mathematical things that are bases and exponents and such that are held together by multiplication and division. So things that are multiplied together and divided together like this, 2x to the third y, that is a term, because what's holding it together are multiplications. I could even throw a division in there, divided by z to the fifth. Everything is held together by a division or multiplication. This makes a term. Now, what separates terms from one another and makes them different terms are plus signs or minus signs. So like 3xy to the fifth, that's another term. And I know these are two separate terms because plus signs and subtraction signs separate out all these different terms. So you see I have three terms here. I have a plus sign and a minus sign, so that means it's breaking my terms up. And notice all the terms, all the pieces of the term are held together by multiplications and divisions. So those are the things that hold stuff together. Now, if you think about this, I just taught you a bunch of exponent rules, and each exponent rule, so just as a way of a very important note here, each exponent rule only applies to one term at a time, or one term, let's go at a time. Okay, so a lot of those rules we cannot combine like bases across a multiplication, or what's this thing called, across an addition or across a subtraction. We can only combine like bases if they're already in the same term. And if there's a plus sign, I cannot do exponent rules. We have another way of combining like terms. Okay, so we now know what polynomials are. They're just when we have one or more terms, many terms. We know what terms are. They're the things that are added or subtracted together, and each piece of a term are glued together with multiplications or divisions. Okay, so what we're going to do then is add or subtract many terms. Now, the important thing to know is I'm only allowed to add or subtract terms that are called like. Okay, well, what are like terms? Like terms are terms that have the same variables and there's an and here. Those variables have to have the same exponents, and same variables, and each variable must have the same exponent. Missed a letter here. Let me try this. Exponent. Okay. So like terms are terms that have the same variables, and each term and each variable must have the same exponent. So for instance, 3xy to the third z. So it has an x, a y to the third, and a z. Another like term to that, it doesn't matter what's out front. Let's go with a 7. X, y to the third z. So if it has x, y to the third z, it is a like term. Now if I have 4x, y to the third z, w, this one is not like. Not like because it has the w. Does anybody see that? So it's not identical. So ignoring the number out front, the coefficient, that's the name of the number out front, they have to be identical back here to be known as like. Okay. Now why are like terms important? Like terms can be combined across additions and subtractions. Okay. So the whole idea of today's lesson is to just simply combine like terms. And we are able to combine like terms by adding or subtracting their coefficients, their numbers out front. So the idea is, we actually look at the operation too. So we have 3 of these plus 7 of these, and that would give us 10 of those. Now notice when I add or subtract like terms, I do not change the term part, just the number out front. I just add or subtract the number out front. And if I have a term that does not have anybody that's like it to add, it just carries down because this is a different term. It cannot combine with this one. Okay, so the whole idea for today's lesson is just to combine like terms. And we already know how to add and subtract. We're just going to add and subtract the numbers out front, keeping the term part the same. Now we're only able to combine the same terms. Okay. So let me give you an example kind of what we're doing today. So I could give you 2 big polynomials like 2x to the third plus 2x minus 3. Okay, so there's one polynomial plus, and let's add the other polynomial, 5x to the third minus 4x squared minus 5x minus 2. So there are my 2 polynomials. I'm adding them. Now if I'm adding them, I can just drop the parentheses. We just show these so you know I have 2 polynomials. So I really can just drop those. I'm going to lazily erase them. May not be the best. You won't be able to erase the writing on a test, I guess, but you can just erase them since it's just adding. If I'm just adding these 2 things, there was no number to distribute, I can just drop the parentheses. And so all we need to do with additions is simply combine the like terms. So I like to underline my like terms. So this is an x to the third. Do you see any other terms that have an x to the third? Oh, this one is an x to the third. Let's pay attention to the sign out front. That's an x squared, x. Okay, so these 2 are x to the thirds. So I'm going to look at their coefficients, their numbers out front, and I will say 2 plus 5. That would give me 7. And remember, I do not change the term part. It stays x to the third. The only time we end up changing these things, the exponents and all that, are when we're doing exponent rules, when we're multiplying. Remember, and that has to be within a single term. Okay, let's see. It's proper to put these in order, like this is an x to this third. The next one should be an x squared. It's okay if you don't, but it's considered proper. Let's see if we have any x squareds. Not one here, not one here. But we do have one right here. I'll underline it with a different mark. That's the only one. Since it's lonely, it doesn't have a term to combine. We just bring down the x squared term, 4. So it's a minus 4, minus 4x squared. So now let's look at the x terms. Let's see, I have a positive 2x. Let's see, oh, there's another x, and a minus 5x. So once again, looking at doing the operation on the coefficients, positive 2 minus 5 makes for negative 3, and I leave the variables and all that alone. They are x terms, so their answer when I combine them is an x. And finally, let's see, I'm running out of symbols I can use. We'll do loops. Plain numbers like minus 3 and minus 2 are considered like terms because they don't have any x's or any variables behind them. but having nothing is considered to be having the same. So if we both are broke, we have the same amount of money, right? We both have $0. So minus 3 and minus 2, that makes minus 5. So there, I have combined all the like terms. That's literally all we're doing today. Okay, now on the test, they can give you these written in funny ways. They can give you what I gave you with parentheses and a plus sign in between. We can just drop the parentheses and combine. Or they can just use words, which doesn't really make a difference, but they can tell you to add 2x to the 5th. Sometimes, some years, they put something like this on the test. Plus 7x squared minus 3x plus 6. And so we're adding that polynomial and this polynomial. 3x to the 6th minus 2x to the 3rd plus 5x squared. This is a big polynomial. It's taking forever to write. Plus 3x plus 8. So we just need to combine all the like terms. You can take the time to write it out again, or you can probably just go about doing this. Let's see, where's the highest exponent? This one's a 5, this one's a 6. So we're going to start with the x to the 6's. And there actually are no other x's to the 6, are there? So we'll just bring that one on down. 3x to the 6th. So next would be x to the 5th. Well, this one's ended up being a lame example. I don't think I have any other x to the 5ths. So we'll bring that down. Now there's no sign out front. I need plus signs and minus signs in between my terms. This is considered to be positive, so that would be plus 2x to the 5th. Let's see, is there an x to the 4th? Okay, no x to the 4th. Let's see, x to the 3rds. I see one, but it's an individual one. That's the only one, so let's bring it down. Minus 2x to the 3rd. All right, x squareds. Okay, finally I get some like terms I can combine. So positive 7x squared, positive 5x squared. That will be, so if I'm adding the coefficients, positive 7 plus 5, that would be positive 12, and I'd leave the x squared alone. All right, let's see. I got, I'll do this, a minus 3x and a plus 3x. So if I add minus 3 and plus 3, that would be 0. So don't write this down, but I could put 0x. Well, what's 0 times x? Just 0. And so that term is just gone. And finally, I have, I'm running out of symbols here. Double a bunch of dots. Plus 6 and plus 8. Positive 6, positive 8. That's positive 14. So that was a really big one. I talked and went really slowly. You can probably move faster than that. But it's also, you don't have to move faster. You can take your time like that. I would suggest you take your time and run through all the different terms and make sure you combine any like terms. This one was combined, right? The 7x squared and the 5x squared. Okay, so that's adding. I want to move on to subtracting because it's almost the same thing. But we do have to kind of worry about one thing. And there's like 3 different ways you could see this. We could just list it out. I'm going to actually use the first example with a minus sign. 2x to the 3rd plus 2x minus 3. And we're going to go minus 5x to the 3rd minus 4x squared minus 5x minus 2. Okay? So this time, since it is a subtraction, I cannot just drop the parentheses. That's pretty much the only difference is I'm not allowed to just drop the parentheses. I have to do something. But what I have to do is distribute this subtraction into the second one here. Okay? And then I can drop the parentheses. So I need to bring down the first polynomial as it is. No changes are made here. But remember, I can think of this as a negative 1, and I need to distribute this negative 1 into all of these terms. So negative 1 times 5x to the 3rd will be negative 5x to the 3rd. So all this is going to end up doing is changing all these signs. So a negative 1 and a negative 4x to the squared, negative negative makes that a positive 4x squared. And if I take this negative 1 to this minus 5x, that will make a positive 5x. And finally, if I take it over here to the minus 2, so a negative 1 and a minus 2 make a positive 2. So all it changed were the signs out front. It made this one negative, positive, positive, positive. Do you see that? And now this is exactly like adding polynomials. Now I just combine my like terms. So adding and subtracting together, there's not really a difference besides making sure you distribute the subtraction. So 2x to the third has a like term with a minus 5x to the third. That would be negative 3x to the third. So 2 minus 5 is negative 3. And I leave the x to the third alone. Let's look for an x squared. Remember, there was one, but it did not have a like term, so I just bring down this positive 4x squared. Then I have a plus 2x, a plus 5x, so this time that is a plus, let's see, 2x's and 5x's. 2 plus 5 is 7x, leaving the x alone. And then minus 3 plus 2, if you're at negative 3 and you add 2, you're at negative 1. Okay? So with this subtraction, it's just like an addition, but first you have to change all the signs of the second thing. You have to distribute the subtraction out. Now, that's all you have to do. But on the test, sometimes they like to give, there's so many different versions of this test that they give, and they give subtractions in so many ways. They may say, okay, well, subtract these things right here, and they list it vertically for some reason. I think they think they're helping. Something like 3x squared plus 5x minus 6, and on the bottom they'll put minus, and they'll put the parenthesis to try to cue you 4x squared minus 2x minus 10. And remember, I cannot subtract. I need to distribute this subtraction, and it's going to change all these signs, and then I just combine like terms. So this will become, I'm going to actually just write this over here. This will become a minus 4x squared, and this will become minus and a minus make a plus 2x, and a minus with the minus and a negative make a plus 10. And so now I can just bring over the top one. It's the same thing we did, just vertically stacked. And thank goodness all of our like terms are lined up. So I did not make any changes to the first one. Remember, we only changed the second one here with distributing the subtraction. And now I can just combine like terms. 3x squared minus 4x squared, that is negative 1x squared. And I don't need the 1, but I'll leave it just because it doesn't matter. 5x, positive 2x, positive 5, that makes positive 7x. Minus 6 or negative 6 plus 10, that is positive 4. So I might rewrite it more neatly without that 1. It does not matter. Okay, so I combined all my like terms. So that's not too bad. Now I will point out one other style that they'll put on the test is they'll use words. They'll say subtract. Whoops, I can't write neat enough. Subtract, and they'll give you some polynomial. Ooh, I have a really confusing one here, which they've taken off the test now. They don't put this one. Let me come up with a different one. 3x squared minus 2x plus 5 from 2x squared plus 10x plus 3. And they do this to confuse you, because remember, subtract this from this. They're trying to give it to you in the backwards order. This is the actual first one when they use the subtract from, and this is the second one. So we already know how to subtract, but really quickly let me just write this down. 10x plus 3. So I write the first one minus, and then I write the second one. So they give them to you in backwards order because that's how we do our English. That's how what that phrase means. Subtract this from this. Remember, that's kind of backwards from how you think. So you would need to distribute the subtraction here. You can just bring down the first one and distribute the subtraction. So minus 3x squared plus 2x. And finally, that would be minus 5. And then I can combine all the like terms. I got a positive 2x squared and a minus 3x squared. That would be negative 1x squared. I have a positive 10x, a positive 2x. That makes for a positive 12x. I have a positive 3 and a minus 5. That makes for negative 2. So there we go. And I'm being really improper not putting my equal signs, but okay. So I hope you feel okay in adding and subtracting. There's something else they throw on this test that we've already done. We spent time in chapter 3, I believe it was, dealing with function notation. And what they do is they bring back function notation, but they want to test your adding and subtracting with function notation. So they do something like this. They'll give you two functions defined. So let me give you two functions. So here's one function. It'll be a polynomial. 2x squared minus 2x plus 3. And let's give you another function. Let's give you, let's name this one g. G of x equals x squared plus 5x plus 4. So they'll give you two functions, which are just polynomials, and they'll ask you, they'll ask the same question that they've asked a million times. Can you plug a number in to one of these? They just keep checking on that skill because it is an important skill. That's not the new thing. Remember, if we do want to plug this in, I suggest you write the function with blanks. Whoops, it helps to copy it correctly, with blanks for each x, and then put in the number -1, and then you literally can type this in your calculator exactly as you see it with the parentheses. That would be positive 2 plus 2 minus 3. So 4 minus 3, that would be 1. Because -1 squared with parentheses, that would be positive 1. 1 times 2 is 2. Minus 2 and minus 1, that would become negative, and a negative make a positive. And then just adding. Okay, but that's not new. We've plugged into functions before. What is new is they're going to ask you to add functions, but that's really not any different than what we've done the whole entire lesson. Let me show you an example. They'll ask you to find f of x plus g of x. Well, what are they asking? They're asking you to add the two functions together. So they're asking you to add this polynomial plus this polynomial. So they're asking you to go 2x squared minus 2x plus 3. So there's f plus g, x squared plus 5x plus 4. And since I'm adding, I could just drop the parentheses and combine like terms. So let's see. 2x squared plus x squared, that makes 3x squareds, minus 2x plus 5x, so minus 2 plus 5. Negative 2 plus 5 is positive 3x. And then finally, plus 3 plus 4. That makes plus 7. So that's all we're doing here, is they're just trying to sneak some function notation practice in. They're asking you with functions, but you just grab the two, what the functions are equal to, and add them together, which is what we've done throughout the whole lesson so far, okay? All right, so that's the way they ask that for some reason, just to practice some function notation. All right, and that's all I have for you today. Looking forward to finishing chapter 5. We have a few more sections, and then we'll hit up this test, and then we'll start talking about the final exam. All right, you guys have an awesome night, awesome day. I'll talk to y'all later.